You can read in the back, right? Okay, sounds good. Cool. Well, welcome to our first viewer seminar in the summer. We got a couple of announcements, and then we will be kicking it off. So, first things first, there is a sign-in sheet, but I'm just going to send it down, and you guys can pass it around if you don't mind. If you see anyone coming in, please pass it along. Okay. Other than that, what else? Nothing's going on. Quinn, the Desert Museum.
We still have a few more spots open at the Desert Museum. We pre-purchased tickets in order to get a good deal, so we have the spots. We just need the people to fill them. And realistically, we'll have at least 1 or 2 people who can't make it the day of, so there's waitlist spots, and I'll text whoever's on that waitlist when I get those cancellations. So also, if you're like a maybe, you can also put your name on the wait list, and I can just text you that there is a spot, and you can let me know if your maybe is a yes or a no, closer to the date. But yeah, just encouraging people to get signed up for that. Yeah.
Likewise, there are also a few spots left. I think we checked before we came to the Desert Museum, there's like maybe 4 spots. There's also about the same 3 or 4 for the ethics retreat, so if you want to join us for that, should be a really cool, fun, interesting time up at Biosphere 2 on June 8th and 9th. If you would like to sign up for that, there's information on the website, but I said I think noon today is the deadline, but I'll do it again today, so if it's on signed by midnight, you should be fine. If you already signed up, you should have gotten a message from me relatively recently. Just save the dates for now, and I'll send you some more information shortly about what to pack and what we're going to eat and all that. All right, big little.
Okay, I have another add-on for Desert Museum. If you're signed up now, you can take yourself off the list. So if you can no longer make it, make sure to do that so that the spots that are available are visible to the other people who might be looking to sign up. And then yeah, we're starting a Europe Big Little program, which some of you might have seen in the Monday message. So just creating structures for you to be in communication with continuing students and to ask questions in maybe like an even more informal locale and one-on-one than small groups. So if you're interested in signing up for that, you can sign up. The link to sign up is in the Monday message from this week. So. Okay. Yeah, we're gonna have our first Europe Ambassadors meeting next Monday at 5 p.m. in Life Sciences South Room 40. So please be there. Any people who are excited to help you plan events and do things for everyone this summer. So I'd love to see as many of you there. I will buy pizza. There will be pizza. Yay! Okay, that's my pitch.
On to our seminar, we have a Europe tradition of having a student who is working in the lab. Our seminar is Adam. Today that is Betty. She's one of our students here at Europe. I would like to make a point, just a quick request. All of our seminar speakers are doing this on a voluntary basis this summer, so I really appreciate their time for being here. And for you guys, if you have a cell phone, make sure it's off. If you have anything distracting, your phones, laptops, or whatever, you can put away and give your attention to our speaker. I would really appreciate that and really take that off. But I will turn it over to you. So I don't know if this one's going to come back to life, but you just ask me.
Yeah, that's all right. I think I can project. Well, hi everyone. It's so nice to see so many of you here today. Like Jennifer said, my name is Shraddha, and I'm a second-year UWork student, and I am very fortunate to work in the lab of Dr. Ying-Hui Chou, who is our speaker today. Dr. Chou is an associate professor in the Department of Psychology here at the U of A. Dr. Chou received her doctoral degree in Movement and Rehabilitation Sciences from Boston University and completed postdoctoral training at Brigham and Women's Hospital and Harvard Medical School, as well as the Duke University Brain Imaging and Analysis Center. She later served as a medical instructor in psychiatry and behavioral sciences at Duke University. In 2016, Dr. Chou joined the University of Arizona, where she established the Brain Imaging and Transcranial Magnetic Stimulation Lab. Her research program focuses on neuromodulation, brain imaging, and cognitive aging.
transcranial magnetic stimulation for mild cognitive impairment and Alzheimer's disease. Okay, so first question for you. So I hope this could be a little bit interactive. So hopefully when I was asking questions, you'll be think of something that you can answer. Okay, so first question for you. In the United States, do you know how many older adults are living with Alzheimer's disease this year? Any idea? Any guess?
About 10,000?
About 10,000. That's a very good starting point.
Is it 80 million?
80 million. Kind of two different extremes. Any other idea?
6 million.
6 million. The most close. Okay, so as of 2026, about 7.4 million Americans aged 65 and older are living with Alzheimer's disease. So it translates to roughly 1 in 9 older adults. So as you can see, this is not a rare condition. It's something that affects a substantial portion of the aging population. And importantly, this number is not stable. So it means it reflects the growing demographic shift as the population ages. So looking ahead, projections are even more striking. So by 2050, the number of Americans living with Alzheimer's disease is expected to rise to approximately 12.7 million. So how old are you during that time? So probably some of your friends, family, or someone you know might start to have cognitive impairment or Alzheimer's disease. So Alzheimer's disease doesn't start at diagnosis. It develops silently over 20 years. So when a person is diagnosed with Alzheimer's disease, 20 years earlier, they start to have pathology in the brain. So first, there's a symptomatic phase. So where people feel normal, but pathology is already building. Then comes the mild cognitive impairment, or MCI, with subtle cognitive changes but preserved independence. So by the time we reach dementia, there's already substantial brain damage. So if we want to make a real impact, we need to shift our focus earlier, like before the significant decline occurs. And that is exactly where our work comes in. So we're using something called Transcranial magnetic stimulation, or TMS, to target these early stages with the goal of detecting changes sooner and intervening while the brain is still modified. So how many of you have heard about TMS? Great, about like maybe 1/4 of people. It's getting better and better every year. Sometimes I remember the first year when I was here, maybe 5% of people heard about TMS. I think we're doing a good job. Okay, so TMS is a non-invasive technique that is widely applied in both clinical and cognitive neuroscience research. And various TMS devices have received FDA clearance for cortical mapping and therapeutic use. So in our lab, we combine different techniques, such as TMS, MRI, you heard about MRI, right? EEG, electroencephalography, measuring neural activity, EMG, electromyography, measuring muscle movement. And we also have lots of different behavior measures and plasma Alzheimer's disease biomarkers. So our work has two main purposes. First, we want to develop TMS protocols that can reliably enhance memory. Second, we're interested in TMS-derived markers, so physiological or network-level signatures that may serve as, we can use that for like supporting diagnosis or prognostic biomarkers. We can predict whether this person, when will they start to have cognitive dysfunction, or treatment response biomarkers. Can we use TMS to say this person might benefit from certain treatment? This person may not, so it's kind of a precision medicine idea. So we want to see, because we don't want to waste people's time, and we want to target the most beneficial individuals who can benefit from certain treatment. So two directions, one for treatment, the other for assessment. But today I will focus more on our work using TMS for memory enhancement. So as you can see here, TMS has steadily gained FDA clearance for a variety of indications over the past 2 decades. So most notably, you can see depression, migraine, obsessive compulsive disorder, and smoking cessation. So for migraine, it's even cooler. So TMS can be a portable device. So for people with migraine, they can have the TMS device, about to speak, bring it at home. So when they start to feel, I might have migraine, then put that in the back of their head to stimulate themselves. Of course, each stimulation is prescribed, so for safety reasons. So it's, I think in the future, we want to see if we can create something like portable memory enhancement TMS, not only for people who already have decline, maybe for people who actually want to boost their memory function. Okay, so it's interesting that while we see FDA approves so many different indications for TMS, but nothing is available for memory enhancement for people with cognitive impairment or people with neurodegenerative disorders. So this is a summary table of FDA cleared TMS protocols and devices. We can circle back to this table during Q&A if you are interested in any of the protocols. Okay, so to understand whether TMS can actually improve thinking and memory in Alzheimer's related condition, so we first look at the big picture of like combining different results from published manuscripts. So this is something called meta-analysis. Have you heard about meta-analysis? Great. So meta-analysis is not, you are not really collecting real data, but you are collecting data from people's articles. You kind of extract information and synthesize all those information to have a very good systematic, quantitative review to tell people what's the current status of this research area in the field. So basically, during the time, not so many articles have been published in TMS, in Alzheimer's disease, and MCI. So at that time, we gathered about 13 studies with about 300 participants. So what we found was encouraging. People who received real TMS, when I say real, because in the study, clinical trial, you have to have real TMS. And you need to have another condition called placebo or sham TMS to compare them, to know there's no placebo effect. Because TMS is so fancy, when people receive that, they say, ooh, I feel like my memory improved. No, we have to control for that. So there are two conditions, and in this meta-analysis, we found that people who receive real TMS treatment did significantly better than those who receive placebo stimulation. And the strength of this effect is very promising, suggesting that TMS has a meaningful impact on cognition in these populations. However, there was an important limitation. So for TMS, almost all the studies targeted like superficial brain region in the surface, because TMS can only directly stimulate the region about 2 centimeters underneath the TMS coil. So TMS coil is like this big. You put certain brain region you want to stimulate. So during the time, people only stimulate superficial brain region because they cannot see where they can target in the deeper brain region. So in other words, instead of focusing on like individual memory network, the same brain regions were stimulated across different participants. So for example, we want to stimulate broadcast area, language area. Everybody stimulated that region. We want to target the dorsolateral prefrontal cortex, everybody target there. So it's not individualized. Why do we need individualized stimulation? Why is that important? What do you think? Any thoughts?
Everyone's brain is different.
Exactly. Everyone has different brain. How can we stimulate exactly the same brain region for everyone? Maybe we thought maybe this is a memory network, but it's not for this person. Very good answer. Thank you. So I think while the results from our meta-analysis was very promising, the targeting strategy wasn't fully aligned with what we know, or we now understand about the large-scale brain networks and individual variability. So in our lab, we have a very specific target. We want to target the parietal hippocampal network. This is the memory network. This is really important when we talk about Alzheimer's disease. So we use MRI as a guide. So think of that like a roadmap. So we started by looking at a region called hippocampus. You can see in this figure the yellow area in the deeper brain region that is called hippocampus. It's a very important memory network region. So for each person in our study, we use the MRI to trace the pathways that link the hippocampus to any other layers of the parietal lobe. So this detailed individual wiring diagram, so everybody has a map of their brain. So we know where we can put the TMS coil on, so we can stimulate the memory network for every individual. So in a clinical trial, we apply this MRI-guided approach to test whether targeting this parietal hippocampal network could improve memory in individuals with mild cognitive impairment. So like you see, we have the coil over different regions of each subject. How do we know we really target the hippocampus? What do you think? How would you know that? What can we observe when we stimulate everyone with the individualized network? What can we observe? Right, so we can have some outcome measures. We want to ask some questions. For example, do you feel like your memory improved after stimulation? That could be subjective because they may feel like, yeah, I do have memory improvement. Or we can use more kind of quantitatively measured outcome measures. I'll talk about that later. We can also use MRI to measure how their brain organization changed after the stimulation. So in this study, we use only just single section of TMS, and we measure memory function before and after the stimulation, and also we have MRI before and after stimulation. In addition to that, we also have the placebo condition. So we want to compare those two, do we see significant improvement? So what is associated memory? So let's go back to this study. So we published a study in PNAS. We actually found significant improvement in associated memory and better communication within the memory network. So let me ask you a question. What is associated memory? You know? Okay, so associated memory is the ability to remember the connection between two things. So like linking face with a name. So for example, when you see my face in the campus, you say, oh, that's Ying-Hui from psychology. So you link those two information together. Or you can memorize two different things with two different words together. So in this task, we actually use something called face name task. It can be used to measure associated memory. So this task has two steps. So in the first step, participants are asked to memorize pairs of faces and names. So for example, if you can see here, okay, so this person is Sasha, and the next person is Stanley, and this person is Dorothy, and that person is Patrick, right? Okay, so you have to memorize those in the encoding phase. And then in the second step, participants are shown pairs of faces and names again. Some pairs are exactly the same as before. We call that intact pairs. So for example, if you see the bottom retrieval face, you can see Sasha. You know, oh, we saw that in the first stage. And some pairs are recombined pairs. So that means the face and name, they saw that before, but they're mixed up. So it's a recombined pair. And the third pair will be a new pair. So for example, Kelly, they didn't see Kelly in the encoding face, so they have to say, oh, that's a new pair. Okay, so participants are asked to decide whether each pair they're shown in the retrieval phase is that a new pair, like Kelly, or it's an intact pair, like Sasha, or it's a recombined pair, like Stanley, because their person should be Patrick. So this is an example of one subject. Their answers like that. So for the first one, Sasha, they answer intact pair. Is that correct? Yes, that's correct. So that's the correct answer. Stanley, they say it's a recombined pair, right? Okay, the third one, Dorothy, they say, oh, that's a new pair. Is that right? No, because Dorothy, that's actually an intact pair. So the answer is wrong. So we had to encode all those information to know how the accuracy rate from this test, before and after TMS treatment. So in addition to the face name associated memory task, we also collect MRI data before and after TMS. So we saw stronger communication within this parietal hippocampal network. So there is a Y-matrix, you can see this blue line. It's called inferior longitudinal fasciculus. So that Y-matrix is very important to connect the stimulation area and the hippocampus. We found stronger communication along this binary track. So what do we see here is we can see people who enhance memory function after stimulation, and they also have stronger communication in their memory network. So kind of suggesting that the stimulation, we're able to target the hippocampal network, even with a long distance between the stimulation site and the deep region in the brain. So we are confident that using our TMS approach, we're able to influence the memory system. And we are very encouraged by this potential effectiveness of TMS. But there was one major challenge. So think about that. Participants have to come to the lab or clinic every day to receive those. It's actually about like a 3-minute treatment. So they come there every day for 3 weeks, 6 weeks, 12 weeks, every day. It's very time consuming. So this could be a main challenge that they have to come for several weeks. So how can we translate this to like clinic or like future treatment? So there is a relatively new TMS protocol called accelerated TMS. We compress the schedule into a few days. So with multiple sessions per day and has shown remarkable efficacy in depression. So the major advantage of this accelerated protocol is that it provides the same total dose in a much shorter time. So for example, if we have 15 sessions, originally they have to come to the clinic like 15 days. Now we condense that into like 3 sessions a day. They only have to come 5 days. So save a lot of time. And for animal study, this kind of treatment protocol is actually more effective because sometimes one stimulation session is not enough. We need to have more to accumulate the plasticity effect. Okay, so this is an FDA-approved accelerated TMS protocol for depression only. So this protocol produces rapid, robust remission compared to conventional TMS and ECT. You heard about ECT? Okay, ECT is called electroconvulsive therapy. It's a medical treatment that uses controlled electrical stimulation to the brain under anesthesia to include a brief, actually can induce a brief seizure and improve symptoms of very severe depression. But there are like strong side effects. For example, cognitive function can be impaired for some people, could be temporary, could be like persistent. So the question is, will accelerated TMS also bolster memory improvement in older adults or individuals with cognitive impairment? So in order to know the answer, my PhD student, Han Bing, in our lab actually conducted a large meta-analysis. So he looked into like more than 60 articles in terms of like accelerated TMS across different symptoms. Shada also assisted with the manuscript preparation and co-authored in this publication in a very high impact journal in biological psychiatry. So beyond depression, accelerated protocol significantly improved anxiety, obsessive compulsive symptoms, working memory, and declarative memory. So importantly, more daily sessions produce stronger effect. Okay, that's for like across different symptoms. So building on this, we launched an NIH-funded clinical trial, comparing, we want to see whether 3 sessions one day is actually better than 1 session a day. So we found that 3 TMS sessions in the same day enhance the communication within the memory network compared to 1 single session. So this is very promising. And also quickly, better communication within the memory network also translated into behavior. So in general, if we only have 1 session of TMS applied to anyone, it can only last for like up to 60 minutes. But in our study, we have 3 sessions of TMS. The effects actually last longer to the second day, like more than 24 hours. So additionally, individuals who show larger increases in the communication with the memory network also show greater improvement in associated memory function. So this tells us that if we only observe the behavior function like memory, we don't know what's the mechanism underlying that. So we also measure MRI, so we have a better idea, like maybe the brain communication can explain the behavioral change after the stimulation. Okay, so far we have been talking about TMS effect, memory improvement and enhanced brain communication within the memory network. In last year, we also published something showing that TMS may actually improve the function of our brain waste clearance system, something called the glymphatic system. Have you heard about this? Glymphatic system? It's something very new and it's very popular right now. Everyone wants to, almost my colleague, they all want to jump into the glymphatic system area because it's a system like clear the waste in your brain. So you know, like Alzheimer's disease pathology, something called beta amyloid and tau. How do people clear those things? It's actually through this glymphatic system. So if we are able to boost this glymphatic system, maybe we are able to see better clearance of the beta amyloid and tau. Okay, so in this study, we found that TMS can improve the function of our waste clearance system, this glymphatic system. So we use something called DTIF, it's an MRI technique, to indirectly measure glymphatic function. So we found that people who are ApoE4 carriers may have worse glymphatic function. So have you heard about ApoE4? Okay. So ApoE4 carriers are individuals who carry at least one copy of ApoE4 allele. So it is a genetic variant that increases the risk of developing Alzheimer's disease. That means if you have your saliva collected, actually people can measure whether you are an ApoE4 carrier or not. And in our study, we found that people, if they are ApoE4 carrier, they have worse glymphatic function compared to those who don't have, who are not ApoE4 carrier. And we also found that after 10 sessions of TMS treatment, those people, they show significant improvement in their glymphatic function. So that means it is possible that TMS can actually enhance the glymphatic system to clear the waste system in our brain. And also we run some correlation to see the behavior correlation and the glymphatic function. So people who show greater improvement in the glymphatic function following TMS also demonstrated larger gain in memory. So this has raised the possibility that maybe glymphatic function can mediate the effect of TMS. So we're talking about mechanism, right? We know TMS can enhance memory function, but why? So this is something we have been trying very hard to understand why TMS can improve memory function. So in this study, we hypothesized that TMS may improve the glymphatic system, kind of leading a better clearance of our brain waste products, such as beta amyloid and tau, which are key features of Alzheimer's disease. And this enhanced clearance may contribute to improved memory function after TMS. Okay, so having shared our work on MCI and AD, you might be wondering, so what else are you looking at? So that's a great question. So our team is driven by the potential of TMS to impact a range of different disorders. And we have been very interested in correlation. So let's switch gears for a moment and I will tell you about other TMS applications. So we have explored TMS effect in Parkinson's disease and multiple system atrophy. So you can see here, if we put the coil over the primary motor cortex, and we can increase the brain activity underneath the TMS coil, which is the primary motor cortex. You know, Parkinson's disease, they have motor symptoms. We found that after stimulation, if we increase the primary motor cortex activity, they actually improve their motor symptoms. And the same protocol applied to the multiple system atrophy, we also see similar effects. We have also collaborated with Dr. Nina Killer at U of A to explore TMS effects on stroke aphasia. So it's a little bit complicated for stroke because, for example, this person has stroke in the left hemisphere. So it creates an imbalance in the brain. So when there is impairment in the left hemisphere, the right hemisphere becomes very dominant, kind of suppress the activity in this region. So TMS has a very cool feature. You can either enhance the activity, increase activity, or you can suppress activity. So what people have done is that, okay, you have like too much activity here, so we suppress here. You have too little, we kind of increase that, so create a balance of the brain. And in this meta-analysis, we found that actually with this kind of combined protocol, you can see like enhancement in terms of language skill in post-stroke aphasia. We also collaborated with Dr. Scott Kilgore from psychiatry department, and we found that also again suppressing the brain activity in a network called default network can actually improve sleep quality for people who have insomnia. So this is another very exciting and important research. And finally, a truly inspiring story. So we teamed up with Dr. Kilgore at Cancer Center, and together we documented something very remarkable. Imagine a patient years after battling cancer. They still struggle with something called chemo brain. You heard about chemo brain? So after chemotherapy, people start to have like very fuzzy thinking, and they cannot concentrate, they couldn't memorize things well. So we actually use TMS 10 sessions, targeting some region called dorsolateral prefrontal cortex. And we found that her memory improved, and also her brain network have better reconnection. And also, even her sleep got better. But there is the truly powerful part. So after 6 long years of this chemo brain, only within months of our TMS therapy, she got a promotion. So she called and said, I got a promotion after this stimulation. But again, because only just one subject, we cannot say it's because of us. But she felt that the newfound clarity gave her the confidence to go for that promotion. So this is just one story, but it adds to the growing hope that TMS could be a real game changer for those fighting to reclaim their minds after chemotherapy. Okay, so here are a few highlights from the therapeutic TMS research. So first, multiple TMS device have received FDA clearance for the treatment of depression, migraine, obsessive compulsive disorder, and smoking cessation. Evidence suggests that MRI-guided TMS developed in our lab improve memory and bolsters communication within the parietal hippocampal network, the memory network. Multiple TMS sessions per day may yield more sustained memory enhancement benefit in individuals with mild cognitive impairment. And finally, TMS can be used to induce neuroplasticity and hold promise as a treatment for conditions such as mild cognitive impairment, Alzheimer's disease, stroke aphasia, chemo brain, and insomnia. Okay, so we have had several excellent university students like you in our lab. We have Gavin, Shada, Carol, Kathleen, Rudy, and Tessa. They're all wonderful. And several of them actually received the WA Frankie Honors College Exploratory Mini Grant to support their wonderful research, and they also went to some national conference in San Diego to present their findings. And some of them have received offer from medical school, some are PhD students in other fields. So I'm very lucky to have wonderful students in our lab. So this work has been highly collaborative. I want to especially thank our lab members, collaborators across disciplines, and our funding agencies. So none of the work would be possible without their contribution. So as you know, we're not only just doing study, we have fun, we have parties, and we went to conferences, so it's a really fun journey for me to work with our wonderful students. Thank you. Any questions? Okay, any questions for me? There's no stupid questions. Anything you're curious about TMS, feel free to. Okay.
Do you have any additional problems with finding the right sample size, or
That's a very good question, sample size. So what's a sample size? Like 5, 10, 1,000? So we always have to do something called power analysis. So power analysis means we either collect pilot data, so maybe 20 subjects or 10 or 5. We use the data to calculate. If we believe the effect is true, how many subjects do we need in order to see the effect? So for the R1, we receive funding from the NIH, it's about 60 people for us to see the effect. Yeah, because if we don't have enough sample size, that's a really good question. If we only have 10 people, we say, oh, we didn't see any effect, TMS is not effective. That would be wrong because we don't have enough sample size to detect the effect. So it's a very dedicated process. Good. Any questions?
How does the magnetic stimulation work for memory? Does it affect the cells? Can it affect your proteins? Is that
Very, very good question. And this is also the direction we're looking for. So we did something called arterial spin labeling, kind of an MRI process.